Welcome to Toy Teardown. In this episode I'll be pulling apart this cool little RC car. It only costs $15 and here's a secret. Let's see what makes it tick. Before I start pulling this car apart, we'll just have a quick chat about it. It is a fully functional radio control car, and by fully functional I mean you've got left and right, forward and reverse. The only difference between this sort of car and a full-on radio control car is the steering, and the acceleration is all digital. So on a flasher radio control car you'll turn a dial slightly and the steering should turn slightly, but in this one it's 100% in either direction. Same with the motor. There's no variable speed, it's just either parked in the garage or flat out. Also it has suspension, front and back, not oil filled shocks of course, it's just like a spring running on plastic. The body comes off, and you can unclip the body, not that you do much with the body of course, you can't get, I can't imagine you getting different bodies underneath. It's just the suspension. We've got a trimmer here so you can adjust the steering, because all these sorts of cars sort of serve off one or the other. If you try and drive in a straight line, it seems to function okay. 27 megahertz. So another downfall of these cars, they were only $15, so we thought cool, we'll buy two and race them against each other, but they're all exactly the same frequency, so you can't run two cars at the same time. In fact, you can't run. We've got a monster truck as well, and they all run on the same frequency. So hopefully when we pull this apart today, I know they use crystals to set their frequency, so I'll be hoping to pull them apart to find a way we can change the frequency of one of these units in the car, so we can at least run two cars at the same time. For the speed, it'll be interesting to look at this gearbox, because it's sort of pretty good, because you hit go and it slowly takes off and then really builds up to quite a high speed. So I'm thinking it's geared in such a way that it's built for high speed, so slow takeoff, which is great for kids, because if you've got a full-on RC car and they first thing they do is pull the trigger and go flat out straight away, and you've lost an ankle, because they are so fast. Whereas these cars, they start off slowly and it gives them time to try and get their bearings and start driving the car properly. So we'll pull this gearbox apart and just see how that's geared, and we might have to swap gears around to give it a fast start and a slow middle perhaps, but aside from that it's all pretty standard. So we will start with pulling the controller apart to see what's in there, and then we'll move on to the car. So we'll get started with the controller here. I'll get the battery cover off. And that's another good thing. The car and the controller take the same batteries. Normally you get a car and the controller takes like a 9-volt battery. This one, all the batteries are the same. So if you get rechargeables, you've only going to get the same type. There's 15 screws, 1500 screws here by the looks of things, so I'll just whip these off. So here's our crystal, and 27.145. So if I get another crystal which is not 27.1.5, I should be able to run two of these cars at the same time. The only problem is, at my local electronic shops, these crystals are $15. So actually it costs more it costs the same for the crystals as it does for the car, so I'm going to have to weigh up that. I might be able to find an old dead RC car around our house and just swap the crystals over. So we've just got a switch, power switch here. It's got a little bit of plastic. an aerial, and it's an inductor there. Let's see if we can see what that chip is. I was expecting to see a chip on board. It says it's a TX2S. So I'll just Google that, bear with me. Okay, so I've looked this chip up on Google, and basically what this does is it makes it a lot easier for manufacturers to make radio control cars. Basically they need this chip and just a few discrete components, and they're up and running along with the oscillator. So I remember when I pulled apart my first radio control car 35 years ago, and it looked like the surface of the Death Star. There was just stuff everywhere. So this has really made life easier for these manufacturers. When you look up the code off there on the internet, it comes up with one which has a lot more pins than what this has. Pins, I mean these little legs that come out the side. And what they've done on this one is utilised one pin for both sort of acceleration for going forward and going back, and going left and go right. So this pin will do forward and backwards as well, and the pin next to it will do left and right steering. So what happens is whenever these two contacts are shorted out, and there's a wiper here, so you pull the trigger back and forward, and it wipes across these two contacts, and then when the contact is made, that's when it says okay, go forward or go backwards or turn left or turn right. When it goes into the pin, it's either full voltage or a half voltage. So half voltage being left maybe, and full voltage being right. So we can demonstrate that. Forward and reverse. Left and right. So it's a cool, pretty nifty little chip. So yeah, it just totally reduces the amount of expense really in making something like this. But the interesting thing is you've got a forward and back pin, a left and right pin, and then you've got an extra pin, and this one was supposed to be in the circuit diagrams anyway, a turbo pin. So it does something else, so it can actually do two other things. And I've tried to see what would happen by just, if I short the pins out, the motor will run, the steering will work, but the third pin does nothing. So it's not being used in the car. So we could use it for a different feature like turning lights on or anything really. So when we pull that apart, it'll be interesting to see what sort of chip they've got in there and whether it's actually been designated to do anything. Let's get started on this car. It's got a removable body, just these little plastic clips. This one's an awkward one. Which reveals the little body inside. It's got suspension, which is basically just springs over plastic, makes a funny clicking sound. This car's been well used, so it's had a bit of a hard life. It's been down to the beach, it's sort of been everywhere really. So I guess we'll start at the front and work our way back. So we've just got a simple DC motor there, which obviously just drives to one extreme to the other. So if they wanted to, they could. No, it'd be probably a bit tricky actually. I was just thinking they might be able to just give it a few pulses, but then there'd be nothing to hold it in position. It's a pretty simple setup. Okay, so this is where the magic happens. I'm assuming this is going to say RX, yes, RX2. So obviously in the transmitter it's TX, transmit, RX for receive, and I'll see if I can fish out which of these pins is actually the one which is not currently allocated to the controller, just to see if it does go anywhere. And again, it's this minimum amount of components to get this going. It's got the chip, a couple of discrete components. Over here will be the transistors to drive the motor. Be interesting, why is there four? Oh, forward and reverse, left and right. Okay, the reason that we've got all these transistors on, transistors are in one form are just switches, so they just switch on high currents from a device which can't handle the current. So current is the amount of amps it'll go through it. This chip controls the whole logic of it, so it receives a signal to turn left or right, it'll turn left or right, or turn the motor back and forward, but somehow it needs to turn the motor on. If all that current went through this chip, it would just disintegrate because it hasn't got the ability to be able to push all that current somewhere. So this is flicking on these transistors. The smaller ones here will be for the steering because the motor is quite a bit smaller, and these larger ones would be for the motor. So it's set up in what's called an H-bridge. So we've got our motor, and our battery, the supply. So these are switches, and it's basically what these things are doing, switching on and off. So we can get the current, so if we close this switch and this switch, the motor will spin this way. If we close this switch and this switch, the motor will go in the opposite direction. So that's called an H-bridge. And that's how it's switching between forward and reverse, and that's why there's four actually, so there's two for each direction. So I'm interested in why there's no crystal on here. So I'm thinking it's got 27 megahertz written across here. So this machine, these cars are blocked to that entire frequency. I'm not too sure. And it's got a tuning inductor there, but I don't think that's got anything to do with it. Looking on the back, we've got the main chip, and I've just checked the pin out, and this pin here is the one that currently does nothing. So we'll try and test this just to see if we do make contact with the controller, whether this changes state, and then if that's the case, then we can get it to do something else in the car, other than just be redundant. So we'll try that now and just see what happens. So I've just wired in a simple switch into that turbo pin, or the fifth function, which seems to have been just not utilised on that controller. And I know it's this pin here, because it doesn't go anywhere on this car, that should react to that being activated. So at the moment, if I measure it, it's dead. And if I flick it on, it goes high. So it's definitely going to work for us. Let's see if I can be a bit ambidextrous here. Yeah, so as soon as I flick it on and off, it's turning the signal on and off. So we can use that to make the car do some other function. But like the driving circuits, I'm going to have to make a transistor switch, because if I try and drive something which draws a lot of current out of that pin, it'll wreck the whole car. So we'll see what we can find within the other toys we can scavenge to make it do something else. I found a victim here. This car, it just rolls and makes a lot of noise. So what I'm going to try and do is pull this apart, get the bits out of this, and then have a switch on the controller here, so when the car's driving around, he can turn his flashing lights on, siren on, whenever he likes. So we'll get into it. So I got the siren and lights out of the donor car. That was, well, it was a nightmare really, because this car was a Tonka, and it was built like a brick. Well, yeah, it was built really solidly, and it was a nightmare trying to get it apart. So I ended up having to destroy the car. I was hoping I was just going to pull off the bits I wanted, and then the kids could still play around with it, but it wasn't going to have a bar of it. So I've got the circuit board and the lights here. Unfortunately, or fortunately, the speaker didn't quite make it. When I was pulling it out, it snapped off all the lugs. So I might try and fix it. But we've got the lights, and I might be lucky enough not to have to build any extra circuitry. Just connect up to these push panels. So this might just be logic level voltages across here, so low voltage, low current, and just switch it directly from that extra pin on that board. So we'll try and hook it up and just see if we can get it to work. Well, I need to find out how much current's going through this switch. I'm hoping it's just going to be logic level, and then all I really have to do is hook the wire up to the switch and it's away. So we'll give it a shot and see what happens. So I've got my trusty Dick Smith multimeter here. I got this just before they started selling meat cleavers and chopping boards. So if I measure across here and here, there's virtually very little current. So looks like I'm going to get away with just hooking this straight up to that pin. 13 microamps, if this isn't remotely accurate. So it's not a lot. So all I have to sort of fudge is the power supply here for the car is only 3 AA's, whereas this car is 4 AA's. So I need to just wrangle up a quick sort of voltage divider or something, so I'm not over supplying this board and cooking that. So we'll wrangle that first and then hook it up to the pin and try it with the controller and see what happens. Okay, this is actually organised chaos. So I got the board out, and I thought each of those buttons did something individually, but they all just do exactly the same thing. You just push it 3 times and you get 3 different chimes 3 times, so there's no benefit in picking. I was just going to pick one off and say just do the siren and the lights, but it doesn't matter. It just does the same action for each button. So I hooked up a wire to the turbo button on the receiver chip, and I tried to connect it straight to this, but this uses some weird 3.7 volt logic and this uses 5, so sometimes it worked and sometimes it wouldn't, so it was pretty unreliable. So I've just hooked it up to a little, don't worry about the rest of this, this is for a different project. This is just a little transistor circuit, so it switches the logic properly. And over on the controller, I've just got a simple push button switch on the spare transmitter button on the controller. So when I push the button, it does actually remotely run those lights. So it is possible to run something else. So I just need to try and squeeze it all back into the car somehow and make it look tidy, and then make sure I can still drive while running these extra bits and pieces. Oh, this controller, I was going to try and use these blanks that come with the controller, because they were obviously designed for a different model car or something, but where these buttons line up go right across the top of the circuitry, so that might be a bit tricky. I might just have to use a different switch to get her up and running, but we'll give it a go. And they flash, so we might just flag that and go for a different push button. We might just use something like that, just drilled in the side. So we'll put it together and see if it still works. I did opt just to use this button on the front of the controller to turn the lights on and off. And all the functions everything else still works, as well as the lights flashing. I gave it just a quick spray with some matte paint because it looked a bit weird with that fluoro green body it did have on it. So in the end I just got old heat gun to get the lights on. Underneath here, let's pop the clips off. It's a nightmare to get off these clips. And just glued the siren unit on the top there. It gave a bit of gap because underneath there is the transistors for running the whole the motors and that, and there's some vents for the heat to get out because they could get hot. So I thought I'd keep that in mind. And the speaker, which I dug out of another toy. All in all, it still goes pretty good. To get the whole thing to work, I needed to make a little circuit board, and I tucked that in next to the steering motor at the front. I'll leave it there for now. I hope you enjoyed the show. I'll leave you with some video of the kids playing with the car and the all-important jump. If you liked what you're seeing today, please click on subscribe or give us a thumbs up. We'll see you next time.